Video 12-2. Phase changes, equilibrium, vapor pressure, and boiling. So, phase changes. Okay, when a substance changes phases, several things have to happen. So, first thing, the temperature as the substance is undergoing a phase change stays constant. Okay? If it's a pure substance, that's the hottest it can get when that substance hits the phase change. Okay? There has to be a change in energy of the substance. Substance either has to gain energy or lose energy. Okay? And the complementary phase change occurs at the exact same temperature. So, water freezes and ice melts at the exact same temperature because these are complementary phase changes. Okay? Now, heating processes. Okay? And don't forget, this is not what happens to the substance, this is what happens to the environment. Okay? So, freezing. Why is freezing a heating process? You say the substance is getting cold. No, the substance, the liquid, has to release heat to the environment. Okay, so the environment ends up picking up heat. Okay, and condensation. Gas turns into a liquid. The liquid has less energy, so as a result, it has to produce a lot of heat also. Okay, and deposition. A gas, depending on the pressure, when you look at the phase change diagrams, doesn't have to go to liquid. A gas can turn directly into solid, and obviously it also has to release heat. Okay. Cooling processes, these are opposite again of what you think. Okay. It cools down the environment because energy is absorbed. So, melting, okay, when you put ice into water, it actually cools down the environment, but the ice is absorbing heat in order for that to happen. Okay. Vaporization, basically, again, when you sweat, the liquid is absorbing heat from your body, and as a result, your body gets cooler. Okay. And sublimation. A solid can go directly to a gas phase, okay. And again, this is going to be a cooling process because it absorbs heat from the environment. Okay. Now, next thing, equilibrium systems. This is a big concept, and it's a pretty simple concept. Okay. So we have a closed system, so matter cannot enter or leave. Energy can go in and out, though. So a dynamic condition can arise. Okay. The forward process, or the forward reaction, and the reverse reaction are both taking place at the same time. Okay. So we said this is what happens when we have an equilibrium system taking place. Okay. So an example: put water in a closed container. Okay. And the water will start to evaporate. But after a certain point, the water level does not drop anymore because condensation starts to occur. So initially, you get a lot of water evaporating, and the water level drops a little bit. But as you start getting more and more of these evaporated molecules, they will start turning back into liquid again. And at some point, the rate of evaporation and the rate of condensation are going to be the same. Okay? And this is what happens when you have an equilibrium condition. Okay? It does not mean that you have to have equal amounts of vapor and liquid, but the rates of both processes will always be equal. Okay, next thing, Le Chatelier's principle. Okay, if the system is at equilibrium, okay, and you do something to the system, you stress the system shifts to basically undo what you just did to try and relieve the stress and get rid of it and bring it back to an equilibrium condition. Okay, so let's say we have a closed system again. In our system, we have our water, and the top is completely closed so it can't evaporate. Okay, we have water evaporating, and we have gas condensing back in. Okay, well, what are some things that we can do? If we increase the temperature of the system, basically what you're doing is adding heat. Okay, in order to get rid of the heat, whatever stuff you add stuff to, it's going to make it shift towards the other way. So the system will shift towards the right side of this equilibrium. Okay, and in other words, you get more liquid turning into gas. into vapor. So in other words, the water level will actually start to drop. Okay, more of the water will evaporate, but eventually it's going to reach a new equilibrium, and the rates of evaporation condensation will be the same. Okay. Decrease the temperature. Basically what you're doing is you're going to remove heat. Okay, so you're losing this. So the system wants to go and replace the heat. So it's going to shift back towards the left side. So you're going to lose vapor, and more of the vapor is going to turn back into the liquid. Okay, so what you'll see then is the water level will actually start to increase, and you'll see condensation taking place. Okay, if we add vapor, you added too much stuff on the right side, so the system wants to get rid of it. In order to do that, it has to shift to the left. Okay, and the vapor turns back into the liquid again. Remove vapor. What happens if you actually just take the top off? Okay, same thing. You just lost vapor, so it's going to try and replace it. So it's going to shift to the right side, and you're going to basically produce more vapor. Okay. Decrease the volume. What effect does this have? Well, if you have a gas, all of a sudden you make the volume of the container smaller. Okay. The system liked the amount of pressure that you had in the system, but now you're going to have a system with a smaller volume, so pressure goes up. Okay. So basically what you're going to try and do is remove the gas so the pressure can go back down again. Okay, so in order to remove the gas, it has to shift to the left side to get rid of it, and you're going to lose vapor. Okay, and this basically produces a lower pressure. Okay, the system's trying to get back down to a lower pressure. Okay, trying to basically undo what you just did there. Increase the volume, doing the opposite. The pressure goes down, so it's trying to make more vapor, so it's going to shift to the right. Okay, now, what if we didn't have a gas? If there was no gas in the system, then neither of these would have had an effect, because shifting it to the left or the right when you don't produce a gas or remove gas, then the volume and the pressure changes would not have any effect on the equilibrium. Okay, now, vapor pressure. For any liquid, as the liquid evaporates, molecules at the surface escape into the gas, and as they escape, they provide an upward force. Okay. This also causes an upward pressure. Okay. This is what vapor pressure is. Okay. Simple as that. Pressure caused by the evaporation of liquid. Remember this. Okay. It's going to come up over and over and over and over and over again. Remember this definition. Don't forget it. Okay. So, what causes vapor pressure? Liquid molecules at the surface, they start to evaporate. Okay. You also have molecules pushing back down again. The same molecules could be other gases, could be the same molecules that you have. But this upward pressure caused by the evaporation of the liquid, okay, this is what vapor pressure is. Okay, now, as temperature increases, what's going to happen to our vapor pressure? Okay, well, you know temperature is directly related to the kinetic energy of the gases. Okay, so, as you increase the temperature, kinetic energy of the molecules in the liquid increase, and as a result, more of them can escape, and you get more evaporation taking place. Okay, so what should happen to the vapor pressure? Vapor pressure will increase. So as T increases, vapor pressure increases. Okay, now vapor pressure for different substances will be different because the vapor pressure is determined by the intermolecular strength, or strength of the intermolecular forces in the liquid. Okay. The weaker the forces, the easier it is for the liquid to evaporate, and the higher the vapor pressure will be. Okay. Now, volatile liquids, we talked about this when we talked about lab safety. These things have high vapor pressures because they're going to have weak intermolecular forces. Okay. So as a result, they evaporate quickly. Okay. Now, boiling. When does a liquid boil? Okay, this is the definition of when a liquid boils. When the vapor pressure of the liquid pressure caused by the evaporation of the liquid, is equal to the external or the atmospheric pressure. Okay, notice, it has nothing to do with temperature. Liquid boiling has everything to do with pressures. Okay, the vapor pressure of the liquid, pressure caused by the evaporation, and the atmospheric pressure pushing down. When they are equal to each other, that's when a liquid boils. Okay. The highest temperature a liquid can get is its boiling point. Once it boils, you can't make it any hotter, even if you add more heat to it. Okay. Boiling point. This is the temperature that the vapor pressure is equal to the atmospheric pressure. Okay. Now, this does not have to be a high temperature. Okay. If the substance has a low vapor pressure, or if the atmospheric pressure is low, then the vapor pressure doesn't have to be very high either. So the temperature does not have to be hot. Okay. So when we say water boils at 100 degrees Celsius, that's known as a normal boiling point. That's the temperature when the vapor pressure is equal to 1 atmosphere. Okay. Then, as a result, the atmospheric pressure, they have to be equal, so it's also going to be 1 atmosphere. Okay, so here's your review question. Will the boiling point of water always be 100 degrees Celsius at sea level? Okay, choose your correct answer and go answer it on the website. Okay, make sure you log in, make sure you remember what your choice was, and also explain why